The Sun has six layers. Three layers, the corona, chromosphere, and photosphere, comprise the Sun's atmosphere or outer layer. The other three layers, convective zone, radiative zone, and core, comprise the inner layers or the parts of the Sun that are not seen. Phenomena that occur on the surface of the Sun. Granules, sunspots, and solar cycle. Granules, upper part of the convection zone of the plasma, which is extremely hot. Sunspots, dark regions seen on the surface of the Sun as their temperature is low. Solar cycle, the activity of the sunspot seems to appear and disappear according to the cycle that left prominences. A solar prominence is a large, bright feature extending outward from the Sun's surface, often in loop shape. It consists of cooler, denser plasma suspended in the Sun's hot corona by magnetic fields. Prominences can last for days or even weeks, sometimes erupt, releasing plasma into space. If directed toward Earth, such eruptions can cause geomagnetic storms. Solar flares. The solar flare is a sudden, intense burst of energy on the Sun's surface, releasing huge amounts of radiation across the electromagnetic spectrum, from the radio waves to X-rays and gamma rays. These flares result from the sudden release of magnetic energy stored in the Sun's atmosphere. They can cause disturbances in space weather, impacting satellites, radio coronal mass ejections. A coronal mass ejection is a massive burst of solar wind and magnetic fields rising above the Sun's corona and released into space. CMEs often accompany solar flares and can eject billions of tons of plasma. When a CME reaches Earth, it can cause geomagnetic storms, disrupt communication systems, damage satellites, and even affect power grids. Solar wind. The solar wind is a stream of charged particles, mainly protons and electrons, constantly emitted by the Sun's outer atmosphere or corona. This wind flows throughout the solar system and shapes the space environment around the planet. It can cause auroras when it interacts with Earth's magnetic field, but can also disrupt satellite operations and communication when intense.
The definition of Earth magnetosphere. The Earth magnetosphere is the region of space around the planet that is dominated by Earth's magnetic field. So basically, it's around Earth, not inside Earth. It protects the planet from the harmful effect of solar wind and cosmic radiation by deflecting most of the charged particles. So deflects the radiation from directly hitting Earth and weakening it. The shape of the magnetosphere is influenced by the solar wind, compressing it on the side facing the Sun, elongating it from a long tail on the opposite side. This magnetic sphere plays a crucial role in maintaining the conditions necessary for life. The formation of Earth's magnetosphere. The formation of Earth's magnetosphere occurs to the interaction between the planet's magnetic field and the solar wind. Earth's magnetic field is generated by the movement of molten iron and nickel in the outer core, creating a geometric dynamo. As the solar wind, a stream of charged particles from the Sun flows towards the Earth, it encounters this magnetic field. The magnetosphere is formed as the solar wind pushes against the magnetic field, compressing it on the side facing the sun and stretching it into a long tail the opposite side on the opposite side. This process creates protective bubble that shield the Earth from harmful solar and cosmic radiation, basically for the same thing. The importance of photosphere. To protect the Earth from adverse effect causing the dangerous particles from the sun or other bodies of the universe. The function of the particle shield protect life on Earth from the adverse effect of solar wind or radiation. Blocks charged particles such as electrons, protons, and alpha particles in the solar wind from reaching the Earth. Third is reducing pressure exerting from solar wind on Earth's atmosphere, or it cause a lot of.
Okay, now we will be seeing the effects from the phenomena on the surface of the sun. Okay, now we will be seeing about the formation of aurora. Auroras are intricately connected to solar surface phenomena such as solar flares and coronal mass ejection (CME). These explosive events release vast amounts of charged particles into space, forming solar winds. As these solar winds reach Earth, they interact with its magnetic field, concentrating near the poles. The resulting collisions between these solar particles and atmospheric gases like oxygen and nitrogen produce vibrant light displays. The intensity and frequency of auroras increase during heightened solar activity, particularly during geomagnetic storms caused by powerful solar events. So, let's see a summary about the formation of aurora. Basically, solar flares and coronal mass ejections happen, which release large amount of charged particles, which create solar wind, and then this solar wind interact with the magnetic field of the Earth, forming aurora. Okay, next is the disturbances to telecommunication and navigation systems. Telecommunication disturbances occur when solar activity like solar flares or coronal mass ejections release high energy particles that interfere with satellite signals, radio waves, and GPS systems. These particles affect the Earth's ionosphere, disrupting long-distance radio communication and reducing the accuracy of navigation systems. Satellites can also experience temporary malfunctions or damage, leading to interrupted services for phone, internet, and other forms of communication. This makes space weather monitoring crucial to mitigate such effects. So basically, this is also actually saying like the solar flares and coronal mass ejections release high energy particles which actually interfere with the signals and which cause disturbances to us. Okay, so here are the pictures that we got from NASA where this shows the disturbances to the telecommunication and navigation systems due to space weather. For example, airline passenger radiation, cellular disruption, radio wave disturbance, radar interference, GPS disruption, and also electric grid disruption. Okay, the third is disturbances in electric power lines. Disturbances in electric power lines occur due to solar activity, particularly during geomagnetic storms triggered by solar flares or coronal mass ejection. These storms cause fluctuations in Earth's magnetic field, which can induce electric currents in power lines. These extra currents, known as geomagnetically induced currents, can overload transformers and other electrical infrastructure, leading to voltage instability, power outages, and in extreme cases, permanent damage to equipment. This makes power grids vulnerable to space weather events requiring constant monitoring and protective measures. Okay, so basically this is like the space weather like solar storms create extra electrical currents in power lines. These extra currents can overload the system, damaging equipment and leading to power outages. In conclusion, space weather significantly impacts Earth, influencing various systems including telecommunications, power lines, and navigation. Solar activity such as solar flares and coronal mass ejections can lead to disturbances that disrupt communications and damage electrical infrastructure. Understanding and monitoring space weather is essential for mitigating its effects, ensuring the stability of modern technology and protecting critical services. As our reliance on technology increases, awareness of space weather becomes increasingly vital for maintaining connectivity and power across the globe. So basically what they are trying to say is that solar activity like flares and coronal mass ejections impacts Earth by disrupting telecommunications, power lines, and navigation. So making understanding and monitoring is essential for maintaining technology and critical services.
No, dadgummit. Jack Schmidt having a few problems. Hang on. Yeah. All right. Good show. I told him you were. What? Okay. We see that one went all the way in. Not quite. But there it is, all but about 5 inches. Okay. Boy, do I like to run up here. I feel like Bugs Bunny. You know the beat. I like to skip along. Not me, boy. Skip. Or whatever you call it. I can't get my left leg in front of me. Dum-da-dum-dum-dum. Dum-dum-dum-dum. Now, I'll give you a demonstration here, Joe. Roger, right on. Here it goes. Spectacular demonstration. Oh, well, enough of that. Lovely. What was that a demonstration of, by the way? It started out to be of gravity, and it wound up being of centrifugal force, I think. Nice soft Navy landing. Wait until you don't know how much fun this has been. We concur, John.